Thank you for taking the time to watch the ProSeries monthly webinar by Protect. The ProSeries content is designed to bring new ideas, strategies, and understanding of topics that help ensure people and processes are safe, equipment is reliable, and companies remain compliant with applicable regulatory jurisdictions. To ask questions, please click the Q&A icon at the bottom of the screen to type your question. We will answer them as they come in or hold them to the end of the call. My name is Nathan Vandergreen, CEO of Protect, and I'll be your host for today. We have a great topic to share with you today about RBI, or risk-based inspection, and how it is an option for your overall mechanical integrity program management. Without further ado, it's my pleasure to introduce you to Stuart Beveridge. Stuart is the RBI Operations Director at Protect. And Stuart, if you could give a brief snapshot of your background to start, I'd appreciate it.
Hey, Nate, thanks for the introduction. Yes, my early career experience in process safety, PHA, HAZOPs, fire dispersion, modeling, risk assessments. Moved to Houston in 2017 to join a company called Houston Integrity Consultants. They were a consultancy company specializing in mechanical integrity, risk-based inspection, and with various mechanical integrity softwares for RBI and IDMS systems. Became the leader of HIC, Houston Integrity, in 2020, and we joined Protect in March of this year through Protect's acquisition of Houston Integrity. Industry-wise, I'm a current member and involvement with various industry groups, including the Gas Processors Association, GPA, the API subcommittees on inspection, mechanical integrity, and also AMPP, who have replaced NACE as the corrosion groups.
And as Stuart mentioned, they joined Protect in 2023. We're very excited to have them as part of our team as we continue to bring more detailed and more robust mechanical integrity services to all industry. Stuart, maybe if you could start off by just giving a background of what is RBI and really where did it begin?
Yep. So RBI evolved really in the early 90s, and it was an inspection prioritization process. So it started as hey, I have a finite amount of time, money, and resources. What's my highest risk assets? And maybe I should focus on them first. From that initial concept, RBI turned into an inspection optimization process and a risk management strategy. So really it turned into what and where are my highest risks? And how can I use inspection to monitor those risks, find damages, and ultimately manage and reduce my operational risk. Which where it turned into now is that based on susceptible damage mechanisms that we can review and predict risk and inspection methods available, what is the appropriate inspection task, method, and interval to inspect this asset? So now the version of our RBI that we're accustomed to now is it's an industry-wide accepted practice with risk-based inspection programs accepted as alternatives to condition-based approaches. And it's widely recognized through API 510 for pressure vessel inspection, 570 for piping inspections, 653 for storage tanks, and 576 for pressure safety valves. Within API, RBI is governed by API 580, which gives an overarching guideline to the RBI process and implementation. And then there's API 581 document, which is a suggested methodology as well for implementation. Really at the heart of it, RBI provides the opportunity to potentially extend inspection intervals and utilize non-intrusive inspection techniques and methods in place of traditional internal inspections. By doing that, we can potentially remove or reduce internal inspection requirements and generally reduce risk and costs, and also the ability to potentially remove or reduce inspection-driven shutdown requirements or turnarounds.
Yeah, Stuart, can you give some examples of where you see RBI being used?
Yep. So RBI is applicable right across the chemical and industrial world. Places that we personally have implemented include onshore and offshore oil and gas production, pipeline networks, chemical storage sites, power plants, LNG facilities, general petrochemicals, desalination, but they can also be used in food and beverage refrigeration systems, really anywhere that's a chemical or industrial world. RBI has been recognized by more and more industry bodies, including OSHA, API, the US Coast Guard recognize it. And it really allows you to create that targeted and optimized inspection program, which is relevant and fit for your operations.
Yeah, and I think one thing to add even to that list is the bio and renewable fuels industry is also something that we've done a lot of looking at, and I think that there's some people on the call that fit that category, and I think there's some opportunities there as well to really add some efficiency and some maybe a better way of looking at some inspections as part of RBI.
Yep, absolutely.
Stuart, can you walk through just how RBI is implemented?
Sure. So RBI implementation typically begins with data gathering and data review. As part of that, we will look at information on your equipment and assets, things like Q1 forms, construction drawings, pipe specifications, things like that. So we look at the asset information, and we'll look at materials of construction, nominal thickness, design pressures, design temperatures, that sort of asset information. We also then look at some process information. So how is it operating, from sample reports to heat material balances, process simulations if they're available, design documents for the process, and really get a better understanding of the process and how it's operating, and some input from operations as well. And we also look at past inspection information, reports and records. So we're interested in things like measure corrosion rates if you've been taking UT measurements, for example. Any damages found if you've been finding cracking, COI, things like that. We really want to get a grasp on what have you found so far. Based on that information, we can combine the asset information, the process information, and the historical information into some risk assessment models, and we can calculate what we'll look at is the consequence of failure and the probability of failure. So things for consequence of failure we would look at is chemical toxicity or flammability, inventory size, the size of the vessel, for example, financial impacts and operational impacts. If a certain asset was unavailable or out of service, how does that impact operations and the consequence side of it? We'll also look at probability of failure. We'll look at things including specific damage mechanisms based on the process and the material that the asset's made of, general internal corrosion, potential external corrosion or corrosion under insulation, environmental cracking, or localized corrosion. So we can look at the consequence of failure, probability of failure, and then we can generate an overall risk from that. Once each asset's risk is assessed and susceptibility to those specific damage mechanisms, we can create an inspection plan to inspect for and to manage those damage mechanisms. So high risk assets will tend to have shorter inspection intervals and requiring higher quality and effectiveness of inspections. So maybe more coverage or a more detailed inspection technique. While some lower risk assets may experience some longer inspection intervals and maybe less intensive inspections assigned to them. At the end of that risk assessment, we can review and say if there's anything which has an unacceptable level of risk or too high, or if there's any mitigation that we can perform to reduce the risk of that asset. Finally, from there, we can finalize that inspection plan, and then it simply becomes an inspection program moving forward. So those inspections are scheduled, complete, and then the thing about RBI is it's a living mechanical integrity program, which means that as you inspect and you gather more data or your process changes, then you feed that information that you've found and you've gathered back into the assessment. So if your measured corrosion rates increase or decrease, then that can impact the risk of that asset, and the next inspection interval may be longer or shorter compared to the previous one.
I think, Stuart, one of the things that when we first met, we used the analogy of a doctor, And one of the analogies is a basic mechanical integrity program today is going in for a routine physical every so many years, right? Or maybe every year. And RBI is really saying we've done an analysis of really what are you at risk for. And we've detailed an inspection program or a review program, or maybe we check your blood pressure every 6 months because you really have a blood pressure issue, and maybe we check your cholesterol now every 5 years because you seem to have that under control based on history, and just creating a more methodical approach that is very fit to your facility and your industry. And that's where I thought, the rubber really meets the road, where you say, this is really specific to you, not just a generalized approach that might be, hey, this is what API standards say. This is more specific to you. So I think that
absolutely. It's all about optimizing the inspection program to fit your operations and making your inspection program fit for purpose. That really you have an idea of what could go wrong, so you can plan to inspect for it, and then based on the risk of that individual asset, then we set inspection intervals and methods appropriate for that piece of equipment.
Yeah, can you hit on how the RBI inspection program would compare to using condition-based inspection programs?
Sure. Yeah. So through the RBI process, you get a lot more flexibility. So in this graph example here, which we pulled from one of our projects, you can see in the blue columns is the typical API 10-year maximum internal inspection. So we see some big peaks in 2017, 2027, and then eventually in 2037. What RBI allows you to do is take into account the individual risk of that piece of equipment and that asset and schedule that task accordingly. So we can see here that we have some extended intervals. So we have our biggest peak in 2031, but it also allows you to substitute those intrusive internal inspections for non-intrusive inspections, because you know where your damage is likely to occur, and you can inspect for them using more modern, advanced, non-destructive testing and non-destructive inspection methods and techniques that are available, because you know where to look for those susceptible damages. So in this example here, I believe we were able to essentially remove those internal inspection requirements and create a non-intrusive inspection-based inspection program, mechanical integrity inspection program, without requiring those internal inspections.
Great. What are the main benefits to owners, operators when it comes to implementing RBI?
Yep, and I think one of the key things is what you touched on a couple of slides ago, is it allows you to inspect smart and set appropriate inspection intervals and methods based on your individual assets and your operations. So what our RBI does is it provides a reduction in risk, as it allows you to focus your time, your effort, your spend where they're most valuable. Inspection tasks which are non-productive, maybe we can remove them. And internal inspections can be reduced or removed as well. So you're also removing that risk from internal inspections of sending someone inside a vessel, as well as the process upsets of the startup and shutdowns. You'll never get to zero risk, because these processes just have inherent risk of you're operating with something high pressure or potentially toxic and flammable. So you'll never get your risk to zero, but really you focus your time, your attention, and your resources and spend on where that damage is likely to occur. Part of RBI also involves a damage mechanism review to identify those susceptible damage mechanisms. So it can also be a valuable supplement to other mechanical integrity program items, or just general process safety studies, things like a corrosion under insulation program. We can help look at susceptibility based on materials and operating pressures and temperatures, and also could be a supplement to a PHA study, because you're identifying and reviewing those particular damage mechanisms that could occur based on your service.
And Stuart, I know you put together a few examples of, of real world implementation of RBI uses and outcomes. So if you could go through and share with the audience some of those, that'd be helpful here.
Yeah, sure. So RBI is a great tool that we can use to get us out of either some sticky situations or just as a mechanical integrity program optimization. So these three examples here are ones that we've completed historically. One of them is a turnaround scope optimization. So we're a facility who were looking to optimize a turnaround. They were a gas midstream facility. If they shut down for their turnaround, then all of their upstream suppliers also had to shut down. They were the only outlet for the gas that was being produced. So they were very, very keen on reducing that turnaround and optimizing that. So we reviewed their turnaround scope and we identified 52 pressure vessels that they could remove from their turnaround scope and inspect after the turnaround was complete using non-intrusive inspections. Ultimately reduced their turnaround time by 42%. So we were able to get them fully compliant and really optimize that turnaround schedule planning. Another one that we had was a non-intrusive mechanical integrity program. So an operator was looking to really optimize a mechanical integrity program. We successfully implemented RBI across all of their process safety PSM facilities to generate non-intrusive inspection programs. We have essentially removed all of their inspection-driven shutdowns from their facilities with significant operational savings from lost revenue alone of those downtime. And we also implemented RBI on their process safety valves, or the PSVs, pressure safety valves, to optimize the testing intervals on those as well. And then a third example is we had an operator with 22 gas plants in West Texas. They were not compliant with their API 510 inspection requirements of internal inspection needs. They had over 4,000 pressure vessels across all of their facilities, and 90% of them were overdue for inspection. By completing this RBI process, we were able to set appropriate inspection intervals and methods, and we were able to get them a prioritization list of their highest risk assets. In less than 5 years, they were in full compliance within 5 years from starting the RBI project and study to completing inspections. In less than 5 years, they were fully compliant with no.
Hey, Stuart, do you have any involvement with regulators in that last one, specifically with when you say overdue inspections? How do the regulators feel? Like, people do get assets that end up past due, and it happens. And when regulators see a RBI program being implemented to get caught back up, or they usually find them far more lenient and understanding when they have a methodical program set up, or how do you?
Yeah. What we've typically experienced is that what the regulators are looking for is that, yes, fair enough, you have overdue inspections, but if you have a plan in place that you are tackling them, and then by implementing RBI, then you can show that you're really assessing the situation and you are going to target your higher risk assets. So that's what they're looking for, is that you recognize that you have overdue inspections, but you have a plan in place that you are tackling them in a scientific and engineering way, that you're not just randomly picking and choosing, but here is our logic behind this, and we're going to tackle our highest risk assets first to reduce our risk. So anytime we've been involved in that process, they've always been very well received and receptive, that you are making a step in the right direction, and here's what we're doing together.
I think a key takeaway in all of your examples is, when you have the ability to provide an actual engineered review and make it a more optimized and specific program to a facility, you have the opportunity to potentially not just reduce inspections, but also reduce the costs associated with preparing for inspections. And when I look at turnaround scope optimization and non-intrusive MI, The reality to it is the inspection, the MI inspection is probably the least cost of the project. The project usually is industrial cleaning and scaffolding, and, replacing internal, whatever it might be, the internal components and even consumables in some of these assets. So I think that there's the big piece to take away from this is, yeah, it can add efficiency to your mechanical integrity program and some specific planning for your facility, but it also has the ability to significantly reduce costs around just the scope that's associated with inspection and turnarounds.
Yep, absolutely.
Okay. With all this data, Stuart, required to implement an effective RBI program, how do you manage it all?
Sure. So there's different RBI methodologies for different levels of data and complexity of operations. We have a software branded as Shield, which is an IDMS and RBI software that allows you to complete RBI assessments, update RBI assessments as you get those inspections complete. Then you can update it and it manages, and it helps with managing that inspection program. So there are other commercially available softwares out there. We obviously feel that ours is better than the rest. We've designed ours to be lightweight and easy to use for end users, including KPIs and metrics to measure and track. But you're right that there can be a significant amount of data behind this, and especially if you are getting an audit, for example, either internally or externally. They may probe and ask to see some of the data and the logic behind your RBI process. So I would recommend, and I think it helps, having some sort of system in place, such as our Shield platform, that helps manage that rather than just relying on Excel spreadsheets. Yeah.
So, yeah, and the one thing with this this program, we do have a question, and I'll wait for most of the questions for the end, but it was asked, does this take the place of something that we've already coined as fit testing that we're already doing for several of our customers? And the answer to that is it can, and there are some overlaps in obviously what that looks like. But to answer that question specifically, this is taking an RBI approach may just be a way to refine what we've coined as our fit or focus integrity testing that we've had in the past. So it's a good question. I think that's something worth some very specific follow-up of this group and with the folks asking the question. So that's really what we had. Thank you for the insight today, Stuart. It's great to see how RBI can help companies take a more engineered and site-specific approach to managing their mechanical integrity programs. I would like to take any unanswered questions that we have from the audience here. And that one I addressed just because it was on the same slide there. But I have a few questions here. First one is, how much data do you need to get started with an RBI program?
Yeah, one of the things I mentioned a little bit earlier is different RBI methodologies are available for different levels and complexity of data and operations. While every case and operation is a little bit unique, where gaps in data do exist, based on the RBI methodology that we're using, we can look to make some conservative assumptions and gaps of data, which can always be revised and updated as more data is gathered. So for that, I would defer to, I would like to review and see what data you have first, and then we can identify what those gaps are and where we can and maybe cannot make conservative assumptions. But as part of that outcome and action items at the end, we would then look to fill in those gaps for sure.
Okay. Second question we have here, do we need to do everything RBI, or can we choose specific assets?
Yep. So RBI can be applied to a whole facility, a whole system, a process unit, or it can be applied to individual assets, maybe troublesome assets that you're finding significant corrosion issues in, that you want to understand the corrosion behind it and how to manage and inspect that better. or it can be applied to a full facility. So yep, you can select individual assets to apply RBI methodologies to. We think that the overall gains to be had for RBI really come when you implement that across a unit or a facility. But no, you can certainly pick and choose, and whether that's as a pilot study or just some troublesome assets.
I know we've consulted with a lot of our customers in the past, just specifically around understanding, what is the risk around each asset having a catastrophic failure or even a partial failure. And, one thing that I would always say is, if you took insurance and you took regulatory requirements and you threw them out the window, what would you do to keep your facility operating? And honestly, the answer to that would be is we would understand the risk of our equipment and the different systems and processes we have, and we would manage appropriately, whether that means we would have a critical spare in place or we were monitoring the health of it very closely because it takes a year to get a new one. And I think that the one message I'd like to make really sure we get across is this is just an approach for mechanical integrity to make sure you could be as smart as possible for your specific facility and your specific industry and application. And that's as simple as we can put it. Last question I have here, unless another one flows in, is if we're wanting to see Shield and kind of what it's all about, how do we arrange for that?
Yep, you can reach out to me at either the phone number or the email address on your screen, or contact us through our website for our Shield software platform. We're happy to do a walkthrough and a screen share and set up some demo space for you to look at that in more detail. Okay.
I don't have any other questions that came through here, so thank you all for joining us today. The recording for this webinar will be emailed out to you as well as posted to Protect's website and YouTube channel for you to share with your colleagues. If you would like to find out more about how RBI can be implemented at your facility, please reach out to Stuart, myself, or your Protect representative. Thanks again, and see you next month.